Alright, let's give this a shot. My regular thing I record on no longer works. Super mega frustrating. It's been a long day. I know you don't want excuses, you want help. Alright. On the test that we're going to take, and hopefully you read the note that it is going to be on Tuesday. As I was helping, I was helping a couple students, I just didn't think that they were quite ready, and I didn't want to send you out there into a buzzsaw just to get your heads cut off. So here we go. This is one type of question. There'll be 4 or 5 of them, I can't remember, on the test, just like this. It's part of the free response. So you'll have math, but you'll also have these. So you need to make sure that you can do these. It says balance and answer the questions relating to the reaction. Alright, so it says solid magnesium. So what we're looking for is the reaction with it balanced, and if it's an ionic reaction, meaning there's spectator ions, we're looking for that. So make sure to include the state. You need to be very exact to get 5 out of 5 on these. So it says solid magnesium. So I start out with Mg and put a solid around it, or an S, I mean. Alright, it's reacted with hydrogen chloride gas. Now this is on the AP test all the time. The final AP test. Hydrogen chloride gas, that doesn't sound right, but if we just name hydrogen chloride, it is HCl. And we are used to that being an acid, because that's hydrochloric acid. But it doesn't say hydrochloric acid, it says hydrogen chloride gas. So this is really HCl gas. It's reacted with magnesium in a closed vessel. Alright, a closed vessel, it doesn't have to be there, but it's just their way of saying that nothing else is involved in this reaction. Alright, so magnesium, let me scoot this over. I always do this. Oops. Jeez. I'm off to a good start already. Alright, so here we go. So magnesium solid reacts with hydrogen chloride gas to form MgCl plus H. And those are the parts, but let's make sure we remember that hydrogen is diatomic, so it's always a 2, and it's a gas. Alright, when hydrogen's alone, unless it's an ion, which this is not a reaction in solution, it would tell you it was in solution if it was. Alright, so it is just diatomic hydrogen, so it's a gas. And Mg, I need to make sure I balance the charge. I have plus 2 and minus 1, so I have MgCl2. Now we might not know, more than likely you would guess, hey, this has got to be aqueous. Remember, AQ means it's in water. Alright, nothing in this problem says that there was water present. So it can't be aqueous. So this has either got to be a solid, liquid, or a gas. It is an ionic compound at room temperature roughly, so we're going to guess, and we would be right, that this is a solid. Okay, so that would be the reaction. I haven't balanced it yet. If you look, you have a 2 there and a 2 there. So I'm going to just take the 2 and put it there. Alright, so now it says to answer the question as well, and make sure you do this on the test. Alright, so the question says which element was reduced. So I'm just going to look at what changed charges. Mg goes from 0 to a plus 2, so it became more positive, so it had to lose electrons, and that's oxidize. That's where Leo the lion says Gur comes in handy. The L-E-O. Leo. Lose electrons, oxidize. Alright, so over here hydrogen's a 0. It was a plus 1. So it became more negative. So we're going to say it has gained electrons or reduced. So you would say hydrogen was reduced. Okay. So to do these problems fully and correctly, you have to include the states in everything. You need to answer the question. If it's something that happens in solution, you need to write it in net ionic form. So let's go ahead and let's do another one with that in it. I'm going to just pause this recording and go to the next page. Okay, so I'm back, and this is the second time. It says sulfurous acid is added to a solution of sodium hydroxide. Would the resulting solution be acidic or basic? Alright, hopefully that'll be a little bit better. Alright, so first off, you're kicking yourself because you're like, man, I remember sulfurous acid, but I don't remember what that was. Well, let's make sure that we can remember exactly how acids work. Sulfurous acid. Well, first off, if it said hydrogen, or sorry, hydrosulfuric, that would just be the plain HS. But it doesn't say that. It has sulfurous, so we know that it comes from a polyatomic ion. And it's OUS with sulfur. And OUS, so we know we're dealing with the oxyanion of sulfuric acid. Alright, so that's SO something. So remember, the most common one is SO4. Alright, but sulfurous means we're one less, so that would be SO3, or it comes from the sulfite ion. So what I'm going to have over here, and this was on your last exam, is H2, that's what almost everyone forgot, SO3. So that's my acid. Now, so I need to know that. That's from chapter 2. Alright, but I also need to know if it's strong or weak, and that's from chapter 4. I need to know if it's strong or weak, because if it's strong, I put AQ here, and if it's weak, I put liquid here. So I would need to check my strong acids. Alright, I'm just going to put them right over here. Strong acids. Pretty much anything with Cl in it, and I'm just generalizing. Br and I, okay, but not F, okay. HF is a very weak acid. It's a very reactive acid, but it's not strong, meaning it doesn't electrolyze. All right, so those three from family 7, and then H2SO4, which is sulfuric, or HNO3, which is nitric. So those are my only strong acids. And if you look at your solubility rules, hopefully you can kind of figure out, hey, that makes sense why these things are the way they are. Since H2SO3 is not on this list, we're going to say it's a weak acid. So I need to put an L, indicating that it's not aqueous in solution. Alright, so all that just for that first chunk. So that's H2SO3 plus solution of sodium hydroxide, so NaOH. Now I need to know if this is a strong base, because then it looks like, yeah, that over there, hold on. Alright, because I need to know what goes in here. Alright, so my strong bases, I'm not going to write them, but strong bases are the hydroxides, meaning the OH of family 1, and sodium is in there, or the heavy family 2 elements. I always forget, but I think calcium and lower. Alright, so since it is a strong acid, I will put a Q in that little box. Alright, and it's going to form something. Let me shrink this down real quick. Alright, so let's go ahead and look at what it's going to make. Now, this is where chemistry is kind of a little bit mean. Because we say this is liquid, which means it doesn't really dissociate, but it still will cause a reaction to happen. Alright, so we have an acid and a base. We should know that always forms at least one product, and we call that water, which is always with a liquid. Alright, plus, so the OH and the H are gone. So now I have Na and SO3. Now let's make sure we remember SO3 is a minus 2, so Na2 SO3. And this is Na, which is always soluble, so we'll put an AQ there. Alright, so that's my complete ionic. Let's change colors and let's come up with my net ionic. Alright, my net ionic equation. I'll just write it down here. Since this is a liquid, I write everything there. Alright, plus, since that's aqueous, plus OH minus goes to H2O liquid, stays that way, plus, this is aqueous, so I have Na, I'm going to say 2 Na plus 1 plus SO3 minus 2. So that's really it in kind of in ion form. So my net ionic, I would cancel out anything that's the exact same on both sides. And it appears as though sodium is the only one that is an ion on both sides of the arrow. So that would be my net ionic equation. And then I finally have to answer this question. Would the resulting solution be acidic or basic, and why? Alright, we have to look, just remember from our reading, we are taking a weak acid and we're reacting it with a strong base. So, in our solution, we will end up with mostly, if you look right here, hydroxide ions and almost 0 H plus ions. Alright, because anything that does come off here to react goes straight here. So if I do have some hydroxide ions, and yes, there are some in there, I'll admit it, but since this is strong and that's weak, we have all of our H's consumed, but OH is still left over. So we would say at the end, it is basic. Now, the only real explanation that you need for this, it's basic because it's a reaction with strong base and weak acid. Now, there is way more confusing math that we will learn how to do to find out exactly what that would be. But just in general, we can figure strong base, well, it must be stronger than the weak acid, so we will end basing. Alright, these problems can be very technical. They're each worth 5 points. Well, that's 20 to 25, because I can't remember if there are 4 or 5 of them on your test. But we did tons of labs where we wrote out the net ionic equation. And try and look through those and think about what you did. And that will help you on that certain section of the free response.